Thank you very much. I'm going to present you what we call the FBI data part. Okay, the purpose of the data part is to, let's say, mutualize all the data management and image calculation, etc., that has been done on the core facilities to try to help everyone on that part. So we have, let's start by the people. We are two mission officers, Perrine, that all of you know, and me. But we have a huge team in the FBI data that are, let's say, most of them are fully paid by France-BioImaging. Some of them are half paid by France-BioImaging. And this is very important. So Guillaume, who is here, is the architect of the development of the data management. Marc Mongy, some of them are directly in the core facilities, and some of them are in the research lab, like Guillaume and Dorian. Marc is in Rennes, which is working on the Homero batteries included. Jean-François, who is a system engineer, who is new also. Theo is here also, is also a system engineer. Guillaume is in Bordeaux for user support and training. Raphaël in Paris for interoperability. Thierry for image processing, and Dorian for challenge. So what is the mission that we have in this part? We divide it in, let's say, 5 different axes. The first one is the role to the community, of course to the core facilities, but also the institutions, the international part, and etc. The second one is to help users and engineers for the data management plan. I will talk shortly about that. The third one, which takes a lot of time for us, it's the data storage, okay, to have a solution for data storage, a generic one. We have 4 axes on the calculus, and I will have only a few things on that because it will start mostly in next years. And a last one, which is on challenges, organizing challenges. So for the first axis, we divide it in different parts, but the role is to our facilities, okay? So we try to help and provide uniform guidelines for the tools. We have also roles to the user and the R&D team. So the research project does not involve only imaging data. Users can now be expert on all data. So we consider that the FBI has the duty of accompanying user in creating their data management plan, and they provide the associated tools. So we have also a role to the bioimaging community. We are a lot involved in the different national and international communities. And we have a role to our institutions to make the link as infrastructures to the institutions, the CNRS, and etc. So what we did on this axis in 2023, we start somewhere to organize some work group on data. Okay. We recommend every node to do this part. We will talk about that for the next years. We start also a blog to try to keep you informed on the improvement on the data part. And we also participate a lot, and especially Guillaume and Perrine on the national and international different working group and conferences. So I will try to cite all of them, but ELMI, ANF, QUAREP, the GT, GDEM with the RTMFM, we are involved in the Equipex of the MUDIS 4LS, and we are also involved in the Group de Travail Open Microscopy. We were in MIFOBIO, not all of us, but most of us. We are in MIFOBIO. We animated 2 different ateliers, one on data management and one on Homero tools by the Guillaume, because we have 2 Guillaumes, and etc. We also organized a table ronde on the data management in microscopy, and we had some flying takers. So this is what for 23. The plan for 24 is to try to have a data reference node for each France-BioImaging node, or could be platform dependent on the structures. So we talked about that yesterday. The idea is that in the working group we have 1 reference per node per data to be sure that the relation between our mission, our tools, our proposals are coming bottom up and top down. Okay. We will also provide the first deployment of the architecture of the Homero. I wrote some MyBot. I will talk about that a bit later. And the purpose is also to open the link to OpenIris to directly have the connection in the metadata with the data and the microscope, let's say. The second axis, we started in 2020. It's to help the structure and the project to make them a data management plan, so plan gestion données. The idea is to, because it was a nightmare at the beginning for everyone, it's to accompany these things first in the structure, sorry, and after in the project. So in 23, we continue the training on this DMP. So I hope that every facilities in the France infrastructure has done these trainings, maybe in 22 or okay. We work also a lot on the involvement on the metadata. Okay, try to think about that, and etc. It takes a lot of times. Okay, so the plan for 24 is to have a machine actionable DMP. That is will be only, let's say, in a few clicks that we will get your DMP. Okay, and we also plan in 25 to have the deployment of these things and the link with all the implementation of the data. So the hacks 3, which take us a lot of time these years, the idea is to provide the tools for data storage. So is it a pointer or? Yes. So the idea is that to put a buffer storage close to the microscope in the facilities in order to have a very fast data transfers. But after this data storage will be synchronized to the data center in UFBI node. And this synchronization should be transparent for the users. That it's completely automatized, but through the Homero interface, the idea that from the user it's completely transparent where are the data, if they are here or here, but just directly after the acquisition they could get access to the data with Homero. Okay. The idea is to this type of data manager has been sometimes already provided in some facilities, but the idea is to minimize the local IT part and do that at the national level. The transfer part of the data is done by something called high road, which the back end of the structures, and the front part is done by Homero. So in 23, it took us many time to develop the architectures, what we want exactly to do. So from the microscope to doing the buffer and the platform, so it goes in these directions, and have all the possibilities if someone comes from the outside of the platform, and etc. So all the situations to be able to develop a model of the architecture of the deployment, which would be consistent for all type of users. So I will not detail that because I'm not able. The idea, we defined the requirement, we did some codec sprint in Bordeaux, and we have an implementation in OpenStack, which is just things to develop very fast the Homero situations in every facilities. They also work at the interoperability in Paris, in Cochin, between some data manager here in Homero and the one which is provided by Cochin, the CID one. So the plan for the next years is a bit charged. So here we are, I will not detail that, but we have many different blocks that we have to develop in order to have the first version in February for some beta users in several nodes in the infrastructures. The idea that we take some 2 months to debug and to add some things on these first deployment versions, to be able to have a real deployment for all users in this node first. And after, I think we miss a part here, but no, it's here. After, the idea that we enter in discussion with the other nodes that need this kind of data managers, that we could be able to provide them the same solutions or adapt this solution, because it's not always easy to provide the same in all different nodes, okay? And after, we will open the doors to the competition part, and etc. So the 4 axes, I don't know the time, but fine. The 4 axes, the first one is on the calculus. So here the idea is to accompany the development towards the mesocenters on the calculus part. So here we will try to be able to provide all the tools that you have, that you use usually, like say in IMAGE or IC, etc., that you will be able to run them directly on the mesocenters. Okay, and also accompany the transition to new tools on IA. Okay, so Jean-Yves will talk tomorrow about BIAS, so we'll not talk about that today, and it's not directly involved in the BI data, but very linked on that. So we didn't. So the plan is to in 24. It's to start to implement some workflow that be able to make the link between the data that are stored in the mesocenters and all the computational tools that you have, that you use in general, okay? So the last axis, we take a bit more time for this one. We start this year in 2023. So the idea is to develop challenges. So the purpose of challenges, there are, let's say, two. One is to develop new powerful methods on high topics that are very important in the level of for users, but also to create open source databases that will be a reference for make a benchmark in the future. Okay, so the team is composed by Dorian, Guillaume, and Thomas and Christophe Edouard, which are, let's say, scientific advisors on this part axis. So here, just to give you an example, two very famous tools that are Stardist and CellPose, they use data that are made specially for challenges. So just to show you that it's very important that this type of opportunities are very give a lot of improvement in these communities. So we had a very short calendar this year. Why? It's because we wanted to submit the first challenge of France-BioImaging to ISB, and the deadline was 27th of November. So it was very short. So sorry for that. So the idea was that we didn't want for the first. So the idea of the challenges in general, it's to do one challenge per year. Okay. Until when I don't know, but one challenge per year. So for the first one, we had to learn many things on the management in general. But to simplify the first one, we put some constraint at the beginning. The first one was to do a challenge in 2D, okay, and also to do it not with manual labels, but to have a way to automatize the labels. You know, when you do deep learning tasks, you have the input and the output. Usually, in most of the cases, the output has to be validated by hand for a segmentation task or classification, etc., which take a long time. So in CellPose, for example, the segmentation has to be done by hand for the validations. So here, for the first challenge, one of the constraints was to do it to have a way to automatize the output by acquisitions. Okay. So for that was a constraint. But for that, we proposed a survey so that we send in every core facilities and etc. So you should have been received this survey months ago now. I don't have the date. And the two main questions was asked in the survey. The first one that what you can do in your platform, okay, and the second one that what do you think that the users will be happy to have to be accompanied with the method in deep learning. So the needs. After we went to a first phase that was okay. Now that we specify a bit the first challenge, we need to see the variability that you can have in the platform, etc. So we did the first phase of data explorations, where we asked the facilities to do some image, like one or two, not much, to see how it goes, how it wears, and etc. To redefine exactly the challenge. And after we get a strong analysis and proposal of the challenge, and so we enter in the second phase. And so we ask for everyone in the France-BioImaging to provide data acquisition, to make the data acquisitions. And so the calendar was short because we asking like for a month to deliver the data for the 27. Okay, so there is the result of the survey. We get some, I think, 45 participants. It was not that easy to understand the result, but it helped us to say that we want to work on a bright field and etc. So it helped us to continue to specify the challenge. So now the objective of the challenge and the constraint was to image mammal cells, okay, at the cellular level. And the idea, and I will show you an image after that, it's to also, when you use deep learning in general, when you use a method, that for people that use a method, for example, in Fiji, you have some methods, usually they are trained on a very specific database, and when you want to apply this method on new images, it never works, okay, basically. So the idea is to profit of the infrastructures, to have a large diversity of acquisition, to be able to train the method on a very different images. And I think this is the force of the infrastructures. It's to really have all the microscope and various acquisition part to really get the maximum diversities. So here we did this framework of the challenge. So what is the task of the challenge now? The purpose is from one 2D images done by DIC, bright field, phase contrast, with a various Z focus, I will show you a bit after, to be able to predict from these 2D images, to predict the 4 organelles, so which are, I don't remember, nucleus, mitochondria, actin, and maybe tubulin, I don't remember exactly. So the idea was to really be able, from one 2D images, to predict these 4 channels, okay, automatically. And for that, we ask people to make an image on the Z stack in order to say that even if the image that will be used for the prediction that will be used by the users is not exactly at the perfect focus, we'll be able to integrate these variabilities of the focus inside the deep learning system, okay? And also one of the constraints in the training database is that not all the people were able to do these 4 different channels. So sometimes the database contains only 1 output, sometimes 2 and extra. And so we asked a lot. So it was a huge time for Dorian to do that. And I will like that we take a break now and upload all of these people who did the image in the France-BioImaging node, because it's very amazing work for that. So I will take a upload for that. Thank you very much. This is very, very impressive involvement of all these engineers. Really, I think they get the project in general, but they don't really know why we want to do that. They don't know what they will win after that, and it's not very clear also for us. It's a project that we do all together, but it's a very, very impressive work. Okay, and we Dorian did some group by the different nodes. So the 2 new nodes were really involved. That was very, very impressive. And the Montpellier node really wins the challenge of the data. That was really impressive. So of course we are localized in Montpellier, and it's a bias. That's normal. So next time maybe we will put Dorian somewhere else, but that's really nice. So thank you a lot. That's very nice. So we get at the end 2,700 images, 3D stack images, okay? Just to give you an idea, cell pose, the cell challenge tracking, you know, it's tracking the cells. It was only 900 images for the database. So we get a lot more images. And also, because they are 2D acquisition with 3D stack, we can multiply this number by 10, because at the end, the training database will contain 10 more different outputs with little variations, okay? So that's very, very nice. With a lot of diversities that you can see for the exactly same framework that was really dedicated. We get very different images. We will remove some images before making the final version of the database, because some of them are very, very too different, but that's a normal step to create data. But that's very, very, very nice. So the calendar for the next year is also very short. So we get officially accepted by Grand Challenge. With Grand Challenge is the portal that supports the challenge. So thanks to Fabrice, the name now is Light My Cells. Okay, very, very nice name. So now we will. Dorian has to do all the things that have been done to have a very nice website support by the 8th of January. We need to give the database by the 15th, so we need to prepare everything, put in the same format, put the metadata, and etc. And it takes time. So maybe Dorian will come back to you if he missed some metadata. So the challenge will be open on the 8th, okay? People will be able to register, and the final registration will be closed at the end of February. We'll have a first test phases where we take, let's say, one image per core facilities, and the idea is to give this image to the user, to the people who will try the method. This test phase is currently in change, and the idea is that people will be able to evaluate their method only on a few images, so we will give them the input and the output that they will be able to evaluate. And the final phase, we keep a few percent of the full database that are completely excluded from the training part, and they will be able at the end to submit their output. In this case here, they submit the weight of the deep learning part, and these things will be evaluated on the final phases by the 30th of April. Okay, and we will announce the result 15 days later. And the idea is to present the result on the challenge in ISB in Athens at the end of May. So we don't yet have the answer of ISB. I think it will be tomorrow or after tomorrow, yeah, something like that. So we hope that we will be selected. Otherwise, everything is will be a bit disturbed, but that doesn't matter. Okay, and we will do, for the first part of the challenge, 2 papers. So just to recap, on the self-tracking challenge, they did, I think, 4 different papers, 2 in Nature Methods and 2 others in other very conference. So it's a very, very important part in the community. So the first paper that we want to do, it's with all the people that did the images. Okay, that's very important. It will be called a data paper to officialize the open source database. And the second paper will be on the competition itself, on the methods and extra to describe the method. So we put some data. I'm not sure about that, but that's the idea. Okay. And yes, so I would like to thank all the engineers that are involved in this FBI data team, with here, Perrine is here, Guillaume, the other Guillaume, Raphael is here, Thierry is here, and Theo is here. So don't hesitate to ask them during the meeting if you have any questions on data and etc. Of course, we'll be happy to help you. We have a mail, which is data at France-BioImaging. Don't hesitate, it goes to every one of us. Don't hesitate to send us any questions or any needs. We are also a lot involved in the Midis for LS team, so I would like to thank them, and especially for the data management plan, etc. We have a Slack if you want to communicate, and thank you very much.